Pamela, what is the double angle identity for sine? Two, yep, equals 2 sine So there is the double angle identity for sine. Okay, let's think about this. What information do we have, class? We have what? Sine but do we have cosine? Talk to your partner. If we have this information, how do we find cosine? Talk to each other. Should take you about 30 seconds. Might be an identity. Ready, set, go. Eduardo? Do you have an identity that can connect them? Okay. What reciprocal identity are you thinking of? So if I get cosine, I need 1 over secant, but we don't have secant. Okay, so we can't use the reciprocal identity. Gustavo? Okay. Which Pythagorean identity?
Sine squared theta plus cosine squared theta equals 1.
Correct. Sine squared theta plus cosine squared theta equals 1. What does that mean? Gustavo recognizes if I take sine and put it into here, square it, subtract it from 1, take the square root, I can find cosine. Aaron, what did you put in for sine?
12 over 13.
Alright, let's do it. Remember, sine squared theta is the same thing as sine theta squared. Same thing for cosine. It's blurry. Is it better? You're welcome. Alright, Aaron. What should we do next?
Subtract it from both sides, so it's over 13 squared from both sides.
Okay. What do you get?
Cosine theta squared equals 1 minus 12 over 13 squared.
And what is 12 over 13 squared?
It's 144 over 169.
There you go. And Aaron, what do you think the 1 is going to turn into?
Common denominator.
Correct. What is that going to be?
169 over 169.
Correct. So 1, put 1 over 1, and then multiply by 169 over 169. And then if you subtract there, what do you get?
You get 15. 25.
25 over.
169.
Keep going.
And then square root it.
Correct. What do you get?
5 over 13.
Square root of 25 is 5. Square root of 169. Really, it's 1 over 169, which is, you said 13? And is it going to be positive or negative?
Positive.
How do you know it's positive?
Because
What does that tell you? Quadrant. Aaron.
because it's in between 0 and 90.
It's in quadrant what?
I don't know.
So, start here at standard position. That would be 90. So this is quadrant 1. And we know that all the trig functions are positive. That's why it will be positive. Okay? Alright, so what do I do with that? Substitute it in here. Okay. Now, I'm just going to multiply all the numerators and then multiply the denominators. If I multiply 2 times 12 times 5, you get? Class. 60 times 2, which will give you 120. And then 1 times 13 times 13 gives you 169. Sine of 2 theta equals 120 over 169. Lucky winner, David! Alright, David, which double angle identity for cosine did you use? Okay, he chose to use the one with both cosine and sine. Now, is that okay to use?
Yeah.
Yeah, because we already have both of them. So let's just substitute it back in. If you want to, you can make it student friendly. And then our yellow is 12 over 13. And our cosine is 5 over 13. Tell us what's right, David. David, what's 5 squared? $13 squared? David, 12 squared? $12 squared. And David, 13 squared. Thank you, Mary. I meant David. Joshua, simplify. Yes, you can. 25 minus 144.
I don't know.
Can you subtract it?
Sure.
So what is it?
Negative 119 maybe?
And we just found the double angle identity for cosine. Remember, you could have used the other ones, but your answer was the same. Yes? Okay. Partner B, summarize partner A, what we did right here, and then you guys talk about how can you find the double angle identity for tangent. Ready, set, go. Alright, help us, Marisol. How did you get the double tangent of 2 theta?
Use the tan. I don't know if I use the 2 tan A equals 2 tan.
Okay, so your paper says tan 2a. Just say it out loud, but don't use a, use theta.
Equals 2 tan theta over 1 minus tan squared.
Does that look correct? Are we missing anything?
The on top is tan 2 theta.
Yeah, we have a 2 there.
2 tan 3.
Okay. Class, we're on our paper. Do we have tangent? Oh. Partner B, tell partner A, how do you get tangent with what we have on here? Macy!
Oh my goodness. You have notes. I think I know this.
Yes, Erica. The quotient identity. Erica, what is the quotient identity?
That's all I know.
Tangent of theta equals...
Sine theta over cosine.
Correct. So sine is 12 over 13 divided by cosine is 5 over 13. If I simplify this, I'm going to flip those. And you get 12 over 5. So now I can use tangent of theta equals 12 over 5. And we can put it in for every time we see tangent. Let's finish the problem. So 2 times 12 over 5 over 1 minus 12 over 5 squared. So now we're just going to simplify this, put it over 1, multiply across, what do you get? 24 over 5. Now I'm going to turn my fraction sideways. 1 minus 12 squared is 144, and 5 squared? 25. So now this one becomes, what does the 1 become? $25 over 25 minus 144 over 25. 25 minus 144. Josh already did it. Josh, what was your answer before?
What?
25 minus 144.
Oh, 119.
Negative 119. This one becomes multiplication, and we take the reciprocal of the second one. 25 over 5 times negative 25 over 119. Remember, 25 is 5 times 5. And then I can cancel my 5s here. Therefore, tangent of 2 times theta equals 24 times 5, which is 120 over 119, and that is negative. Now remember, this is twice the angle, so you're not in quadrant 1. You'll be in quadrant 2. So, what do we do in this problem? We were given the information sine of theta equals 12 over 13, quadrant 1. We were asked to find the double angle identities. Notice how you're using the other identities to help you find the ones that you need.